Today I'm going to teach you about movements in the coordinate plane. Hello, I'm Andres Oyuela, 11th grade student and your tutor of this topic. First of all, what are they? They are movements experienced by a two-dimensional figure in the Cartesian plane. They can be any figure, be it a line, a square, or a triangle, whichever you want. We're going to see three: the translation, the rotation, and the symmetry. First of all, we need to know that the coordinate plane is divided into four quadrants. The first one has positive x and y coordinates and is shown with a yellow box. The second quadrant has negative x coordinates and positive y coordinates and is shown also with a yellow box. The third quadrant has both negative x and y coordinates and is also shown with a yellow box, as you can see. And the fourth quadrant has positive x coordinates and negative y coordinates and is shown with a yellow box also. So you can know it's divided into four quadrants. Now, you can put points into the coordinate plane, so every point has an xy coordinate, where the x represents the horizontal coordinate and the y the vertical one. So, if you have a point with coordinate 4 and 2, it means it has 4 horizontal units to the right, shown with the yellow arrow, and 2 vertical units up. So the point ends up in here. Now, if the coordinate is -2 and 3, then it has 2 horizontal units to the left and 3 units up. When the x is positive, it moves to the right. When the x is negative, it moves to the left. And when the y is positive, it moves up. And when the y is negative, it moves down. Now we can begin with the movements, being the first one, the translation. A translation is when a geometric figure slides up, down, left, or right in the coordinate plane. So imagine the spaceship has to go to a planet in order to save the world. First he moves horizontal right, and then he moves vertical down, arriving to the planet. Now we are making the same movements but with numbers. The spaceship is in coordinates -3 and 1, so he is horizontally 3 units left and 1 unit up. First, he does the horizontal movement, so he ends up in 4 and 1, because moved 7 units right. Now moves down and it ends up in 4 and -1, moving 2 units down. So the rocket moved 7 units to the right and 2 units down. Now we have a rectangle, where we are asked to move it 4 units to the right and 2 units down. To make this, we can create points in the edge of the rectangle, where you can see the coordinates of each point. Now we move each point 4 units right, so we finally move the square. Each new point has a new coordinate and is shown in the presentation. And then we move it 2 units down, so these are the final coordinates of the rectangle. Now we are asked to move it 3 units up and 1 left, so we move each point 3 units up first, and then 1 left. Now that we finished the first movement, we are with the second one, that is rotation. A rotation is a movement that a geometric figure performs from a given point. You need to know that the size and shape of the figure remains the same. Also, the rotation is measured in degrees, so the first rocket moved 90 degrees clockwise, the second rocket moved 180 degrees clockwise, the third rocket moved 270 degrees clockwise, and finally the fourth rocket moved 360 degrees clockwise. Now, the first movement moved 90 degrees anticlockwise, the second 180 degrees anticlockwise, the third one 270 degrees anticlockwise, and the fourth one 360 degrees anticlockwise. So when we talk about rotation, it's not like this. It is like this, where you have a rotation point or a given point and you rotate the figure taking into account the rotation point. So in this figure it moves 90 degrees clockwise. And here's another example, when it rotates the figure 125 degrees clockwise. So there are some steps in order to make a rotation. First, you need to join each of the vertices with the center of rotation, or the given point with a line, shown in the presentation. Now you have to measure the given angle with respect to each of the round lines and put a point. You can do this with the protractor. For instance, we have the line A and we put the protractor in the line. We measure the angle that we are given, or in this case 90 degrees. Then we put a point and we are going to name that point A prime. After that, we need to draw a line from the point of the rotation to the point created, shown in the presentation. Now we are going to repeat the same 2 steps, but with point C and B. We put the protractor in line C, we measure 90 degrees, we put a point, we name it, and we then draw a line. between the new point and the given point. Then we repeat with line B. We put the protractor, we measure 90 degrees, we put a point and we name it. Now you have to measure the distance between the points of rotation and the corners of the figure. And you have to put the same distance on the new line and mark it with a dot. For instance, we, with a ruler, measure that the distance between the given point and C is 3 centimeters. In the new line, we measure 3 centimeters. In the new line, we measure 3 centimeters and we put a dot in the 3 centimeters line. And we repeat this with all the lines. For instance, we measure that distance B and the given point is 1.3 centimeters. Then with the new line, we measure 1.3 and we move the point. And then we repeat, but with point A. We measure that the distance A is 3.6 centimeters. Then with a ruler, we measure in the other line 3.6 centimeters and we move the point. After that, you can remove the lines and the points are joined to create the new figure, just like this. You need to note that the size and shape of the figure remains the same. The third movement is named symmetry. First of all, we need to know what is the axis of symmetry. The axis of symmetry is a line that divides a figure into two equal parts. So, imagine we have a cat. We draw a line that divides the cat into two same figures. As you can see, the left part of the cat is the same as the right part of the cat. Now we divide it. But imagine we lost one of the parts of the cat, so we only have the right part. We draw a line where we want to do the symmetry. We move like that the figure. And as you can see, it's like the same but with symmetry. It's like when you look into a mirror, it's basically the same. And you can see the new part of the cat completes the cat. Now we're going to see it in the coordinate plane. For instance, if you have a moon with a star, you're going to do the symmetry with the y-axis, and it's shown in the presentation. Now, as you can see, the distance between the moon and the y-axis is the same in both. Like the yellow arrow is the same distance that yellow arrow. Also happens with the x-axis. Like the blue arrow has the same length of another blue arrow. Now we do symmetry, but with the x-axis, where the red arrows have the same length and the yellow arrows have the same length. You need to know that the signs remains constant. So we're asked to reflect the triangle first on the x-axis and then on the y-axis. So you can see there's a point that is 2 and 1 in the original figure, so you can know that the distance between the x-axis and that point is 1, because it has one vertical unit up. Then when we do the symmetry, it's shown in the presentation, and you can see the new dot has also one distance between the x-axis and the point. Now imagine we are given an axis of symmetry. In this case, we're going to put a line, and it's the axis of symmetry blue. First, we measure the distance between each point. For instance, the point 3 and 3 has 2 units of difference to the axis of symmetry, and when we reflect it, it also has 2 because it's in -1. So -1, 0, and 1. It has 2, and the original figure is 1, that is the line, 2 and 3. 2 and 3, that's 2 units also, so it's the same. Thank you so much for hearing. Do you have any questions?